Hi everybody, it's DanceDev, and today I'm going to show you how to create a scalable API in Go, then Dockerize it and deploy it to the Kubernetes. I will do it from scratch in roughly 30 minutes while sipping a coffee and describing my thoughts as I go. The project I'm going to create is a simple bulletin board where you can only add and retrieve bulletins. For the sake of simplicity, I will use Gene Framework and Postgres database. First, I'll create a project. I'll call it a bulletin board. Actually, I'll call it Bulletin API. Then I'll create a main file, and then I'll add a configuration to it. Then, because we're gonna use PostgreSQL, we need to import PostgreSQL. Then I will define structures and constants. The first, I will define the host. The host will be DB, then the DB user will be PostgresDev. Then I will define the password. For the sake of simplicity, I will just define all the variables here, so I don't need to spend much time defining it in secrets and files, you know. The name will be that, and I'll create a simple table. Literally, we'll define a migration here. It will be something like create table if not exists bulletins. Actually, it's not really good this way. It will have ID, serial, primary key, and author, tags not null, content, tags not null, and create it at timestamp with time zone as default, and it will be current timestamp. So now I need to define a structure for that. I'll call bulletin struct author string JSON author, and then I'll also define binding because I'm gonna use a framework that will work with this binding. Content is also required. This means that during the serialization this field is a must. Time, and this one doesn't have to have binding, but it will be created at. Okay. Then I'll need to define a database. It will be SQLDB. Then I'll probably need to define a couple functions in order to get my data from the DB and post it in the DB. And the second function is to post a bulletin. For now, we'll just return nil. So now I'll need to define my endpoints. I will use Gene Framework. It will be a default framework just for sake of simplicity. And then I go board. It will be the method where we actually get the bulletin from the board. Then we define get this bulletin from the board, and then if there's no error, we should. I mean, if there is an error, context will oh my god. Context JSON. It will reply internal error. And Gene H status internal error, just like that. Oh, of course. Yeah, and now we just return it at this point. Now see JSON context JSON HTTP status. Oh my god, status. Okay, and now we're just gonna return the results. So this will be our get function. Now let's do a post function. Post board function context, and then we need a bulletin. And we need to, and now we're gonna use the bindings. I keep calling this seeds context. Bind, and now we're just gonna bind it equal nil, and we just going to create a timestamp. Now we're just gonna add a bulletin through our database, and if there is an error, we should save that there is an error. We're gonna scream to the context, so we're just gonna copy that one. And if everything is alright, we're just gonna reply that everything is alright. This is how we're gonna do it. Status. Okay. Alright. Now, as we define two functions, we need to actually connect to the database. And this is how we're gonna do it. Printf host user equal password equal db name equal and SSL mode. Just disable that one. Okay, now we're just gonna pass it the host, pass it the user, pass it the password, and pass it the name. Okay. Now we're going to actually connect db error equal to SQL open. Postgres is our database db info, and if error not equal to nil, panic error. Not really doing any much error handling here, just in the sake of simplicity. Then now we're gonna query the migration, so we make sure that our table exists. Of course, we need to check if it actually did what it's supposed to do. Failed to run migration. Error. Okay. And now we're just gonna close the DB. Oh, did I already close the DB? I did. Don't need to do it anymore. Yeah, now that's basically it. Now we're just running the server, and this is how we're gonna run it. Run. Just gonna write it on 8080. Error not equal to nil. Start, and then panic if it's an error. Okay, time for coffee. Okay. Now we've done that. Now bulletins. Yeah. Now we're gonna define functions, and in the get bulletins we need a simple SQL to run. Select author content created at from bulletins order by created at desk limit 100 just in case. Now we have this query, and we're gonna run the query in the database. Query Q. This is not the best way of doing things. You better use prepare and stuff, but just in sake of simplicity for this particular one, I'm gonna do it this way. Alright, now we're just gonna make results bulletin 0. It's dynamic allocation. Could have done it better, but in this case, just want to do it fast. Author string, then content string, and then created at, it will be time. So now we need to scan the rows, and I'll pass it the author, I'll pass it the content, I'll pass it the created at. Check the error, obviously, nil error. Okay, then now append the results. Append results, and I create a bulletin structure with the data we just got from the database. Okay, great. Now let's fill this function up. So we also need a query for insertion. Into bulletins. Did I call it bulletins? Yes. Bulletins. Author, content, and created at values 1, 2, 3 values, and error. And now let's just execute the query with the parameters we got from our structure. Great. And we'll just return error. Okay, this should be it. Let's compile it to make sure it works. It's compiling. Great. Fails obviously because it can't connect to the database, and in order for us to make a database up and running, we'll create a Docker file. First, we will fill up the Docker file to create a container, and then we will put this to the Docker Compose B CRC, and I'll call it bullet and API. So now we switch to the working directory. API, and then I will copy the content of that folder to our container. Now I need to install my Go program, and in the CMD I will just run it because it's already installed in the binary folder. So now I can just run it, and I will expose port 8080. Alright, great. Now we have a Docker file. Now we're going to create a Docker Compose. Okay, so the Docker Compose file will contain of 2 services. I'm going to use the Docker 3. And the first service will be DB. And I'll call it bulletin DB. Image Postgres, host name DB. Environment. For the environment, I will get hosts from DNS and Postgres db def Postgres. User will be Postgres def, and Postgres password will be my secret password. I misspelled it. I'll just copy that to make sure it's the same password. Great. I misspelled it both times. My secret password. Nice. Okay, so now I will define ports. 5432, 5432. This is a default port for PostgreSQL. The networks, I will define the network. I will call it bullet and nat, and I will define it below a little bit later. Now bullet and API itself. Container name will be container name. Just copy that. Container name will be bullet in API. Image. I just use my username with bullet in API versus version 1, and the host name. Yeah, the host name will be just bullet in API. Now build. Just omit the context. Then Docker file will be Docker file. I think it's by default Docker file, but just in case I'll define that. Then environment, difficult word. Get hosts from DNS, and the network will be bulletin net that I will define below. Now volumes. I will just define the volume as the directory that I have in the container. Bullet in API. Is that what I call it? Yes. Oh no, really. This is what I call it. Okay. Now ports. The port I'm going to use is 8080. Okay. And it will depend on the DB. Also need links to the DB and labels, because we're gonna use compose later. We're gonna just define it right here. Okay. Then you finally need to define the network. And it will be a bridge driver. Okay, this is how our compose file should look like. Something like that. I don't think I missed anything. Okay, now let's create a compose, Docker compose configuration and see if it actually works. Okay. Apply. Compose. Let's compose. Error, the code is invalid, blah blah blah. And support configuration services DB. Built-in API. What? Oh, okay. Yeah, the indentation is very important. And the network, probably, too. Okay. Now let's try to compose. Oh, we need to pull the DB too. But at least it's compiling. Yeah, it's pulling the images. And what I just realized we also need to do, we need depths, because we need a vendor directory. It's my old stuff, dep init. Initializing the dependencies is gonna put all our dependencies in the vendor directory right in the project. Now we're gonna dep ensure. Okay, now we get our directory up. Now we can indexing quick and then compose again. I didn't press it. Oh, by the way, it could mess everything up. Let's quickly review that. And one more thing. Right. Okay. Now try to compose again. Has been deployed successfully. Database is up. Connection refused. Why? Let's try one more time. It's gonna recompose. Let's try it. Localhost 8080. Yeah, the APIs seem to work. Okay, it's good. Now let's do one more important thing. We need to push this image to the Docker Hub. And also, we would want to compose and prepare all our files. Sorry, volume mount on the host not supporting any of that. That's okay. Yeah. Now we have all our files prepared for deploying to Kubernetes. And while we're going to create some other file, we're also going to create a Kubernetes cluster. I already signed in with my account, so we're just going to create a new cluster. Bullet in cluster 1 create. It's going to create a cluster for us, and meanwhile we're going to create a file that will help us in deploying. And this file, what it's going to do is going to create everything for us, and we just need to give it all the file names, all the YAML files that were created with compose. Okay. Okay. This guy's just gonna copy his name and this guy name. Okay, great. Bulletin API. Yep, everything seems to be right. Great. Okay, we just save that. Our cluster up. No, yeah. Okay, let's just give it a bit of time. Yep. So this file gonna help us in creating all the services and deployments and persistent volume which is basically going to create everything for us. Now, I'm going to this directory, and I'm going to create a zip file. For the sake of simplicity of this project, I'm just going to upload the zip file to the Kubernetes cluster itself. Okay. Refresh. Meanwhile, I'm going to connect. Try to connect to the virtual machine. It's not created yet, but we'll wait. Yeah, here everything should be alright. And we established the connection, but we will wait for a little bit until it says, oh, it's ready. Good. Now, fetch the cluster endpoint out of data. We are authenticated, and we will upload the archive. Good. Now let's just unzip it. Ooh, so many files, including all these garbage files, but whatever. Now we have all of these, and we probably need to sh mode the shell file so we can execute it. And now we're just going to call it, and it's going to create all the deployment and services and persistent volumes for us. Service created, deployment created, building API, nice, everything is up. Let's just look at the workload right now. Yep, it's loading. Need to give it a bit of time for it to build. Okay, database is okay. The load balancer takes a little bit longer to appear because it has endpoints to create and expose to the network. Just need to give it a bit of time. This is our serving pods. And let's look at the log. Container is always waiting. Just need to wait. Creating services endpoints. Yeah, for it to be exposed to the actual network, it's take a little bit of time. Container log. Pod details. Okay. Okay. Great. Let's try it out. Okay, now our application is deployed to the Kubernetes, and let's try to add some bulletins. To add bulletins, I will use Postman. And we'll just use this IP board, and we're gonna have a pre-made body for a file such a boss command Kubernetes. Nice. Posting. Okay, status is okay. So now the bulletin went to the database. It's written in the Postgres, and now let's try to get all the bulletins that are in board right now. There we go. And this is how you create a scalable API in Go, Dockerized, and running on Kubernetes.